All right, guys. In the last video, we're going to go over questions 43, 44, and 45. And I want you guys to analyze the question carefully. It says, if you are dealt 5 cards from a shuffled deck of 52 cards, find the probability that all 5 cards are pitcher cards. Now, before I get into that, I want to restate the theoretical probability formula. The probability of an event equals to the number of ways the event can occur divided by the total number of outcomes in the sample space. My event is specific, and it's usually the question being asked. My sample space is what I have in general. And that's usually the information provided to me in the question. The essential information. For example, looking at this question, I'm going to look for my sample space first. It says we are dealt 5 cards from a well-shuffled deck of 52 cards. You're dealt 5 cards from 52. That is my general information. So this right here will consist of my sample space. What are we trying to find? What is specifically we're looking for? We're specifically looking for that all 5 are pitcher cards. Now, focusing on the sample space first. We have 52 cards in my deck, and we are choosing 5. 5 is being dealt to us. On a general level, and I repeat, on a general level, it doesn't matter which 5 cards we are being dealt as long as we have 5 cards. Each card is distinct with a different color, a different value, and a different suit. Once a card is dealt, that card cannot be repeated again. When the order doesn't matter, when we're choosing distinct objects, and when repetition is not allowed, we are using combinations. So for my sample space, for number 43, it will consist of the combination of choosing of having 52 cards and being dealt 5, in which the order of me being dealt the cards doesn't matter. We're going to do a combination once again in our calculator. Let's open up that bad boy. And remember, you type in the first number, which is 52. Go over the math. Use your arrow to go over the PRB. Combinations is the third option. Put in the second number, which is 5. And that is going to equal to 2,598,960. So now let's look for the event. The event says the probability, or rather, that all 5 cards are pitcher cards. Now remember from a couple of problems ago that pitcher cards are represented by face cards. There are 12 pitcher cards in my deck. And in this case, we want to have all 5 being dealt are pitcher cards. The order doesn't matter in which you receive the pictured cards, and it doesn't matter which picture cards you received as long as you receive the picture cards. Once a card is dealt to you, that card is not replaced. So once again, that is going to be a combination. That is going to be a combination of 12 picture cards and 5 is being dealt to you. Let's find the combination of that value. Let's clear that. 12, go to math. Oops, let's do that again. 12, go to math. It's already on PRB. Go to combination, put in 5, hit enter. That equals to 792. So the probability of this question for number 43 is going to be the event, which is the number where the event can occur, which is going to be 792, divided by the number of ways the sample space can occur, which is 2,598,960. The answer on the answer key is in a fraction, a reduced fraction. So having that TI-83 or 84 calculator, divide your fraction. So that's going to be 792 divided by 2,598,960. After that, you're going to convert that decimal into a fraction by going to math. You're going to go here to the first one that says frac, convert that value into a fraction, hit enter, and that's going to equal to 33 over 108,290. All right, guys, that is going to be it for question number 43. 44 and 45 will follow down the same path. It says here, and a five card hand is dealt at random from a standard deck, which is 52 cards. What is the probability that the hand contains exactly 2 face cards? The good thing about number 44 and 45 is that the sample space will remain the same. I just need to find the event for question number 44. Now, the event says we want to find the probability that the hand contains exactly 2 face cards. Remember, the can must consist of 5 cards. If we want to find the probability of being dealt 2 face cards, we also must consider the fact that there are 5 cards in the hand, which means if I'm dealt 2 face, I will also be dealt 3 non-face cards. Because once again, I must have 5 cards in my hand. If 2 are face, the other 3 has to be any other card that is not a face. In my deck of cards, there are 12 face cards. I am choosing 2 face cards. It doesn't matter which 2 I'm receiving, nor does the order matter that it's being selected to me. And once I have a face card in my hand, that face card is not replaced. So it's going to be the combination of 12 face cards. You're choosing 2, and the order does not matter. The word "and" when it comes to combinations and permutations means multiplication. There are 52 cards in my deck. 12 of them are face, which means the other 40 cards that's in my deck is not face. We can do 52 fit cards overall minus 12 face cards, which means there are 40 non-face cards. And out of the 40 non-face cards, we are being dealt 3, and the order that I'm being dealt the face cards does not matter. So let's calculate those combinations. 12 Go to math, PRB. Oops. Try that again. 2. We're going to multiply that with the combination of 40 and 12. Sorry, 40 and 12, 40 and 3. Let's clear that. 3. That equals to, put that in black actually. $652,080. Now, to find the probability in this case, we're going to take this 652,080 and divide it by the combination of 52 cards in my deck, and I'm still choosing 5, which is 2,598,960. So divide that by 2598960. And I want to round to, let's get 3 numbers after the decimal. 0.251. Because that 9 will make that 0 round up to a 1. You know, actually, nah. I want to round this to 4 numbers after the decimal. So 0.2509. We'll give that 4 numbers after the decimal. All right, guys. Hope that makes sense so far and you guys are following. Let me clear my calculator. And let's do the last question from the review sheet. Number 45. And once again, the sample space still remains the same. A 5-card hand is dealt at random from a standard deck. What is the probability that the hand contains exactly 3 red cards? So the event is exactly 3 red cards. There must be 5 cards in your hand in total. If 3 of the cards are red, I must choose 2 non-red cards. And if the cards are not red, they are black. There are 2 colors in my deck. There's red and there's black. If I'm choosing 3 red cards and I'm having 5 being dealt to me, 2 of the cards must not be red, which means the cards must be black. There are a total of 26 red cards in my deck. I am choosing 3, and the order does not matter in how I choose those 3 red cards or how they're dealt to me. The combination for the next one will be 26 non-red cards, which means there are 26 black cards, and I'm being dealt 2 black cards. And the order in which the black cards are dealt to me does not matter. And once a card is dealt to me, I am not replacing that card back into the deck. So that is going to be for my event. Let's calculate that in the calculator. So that's going to be the combination of 26 and 3 times the combination of 26 and 2. And that's going to equal to 845,000. Therefore, the final probability of having exactly 3 red cards, that is going to be 845,000 divided by 2,598,960. I'll take 3 numbers after the decimal in this case. So 0.325 13. All right, guys, that is it to the entire review videos series for exam 2. This is a way longer review sheet than it was for exam 1. Please remember to review exam 1's material. Let me zoom out so you guys can get a good picture. Well, let me pull it up actually. Of questions 43, 44, and 45. Once again, the PDF will be available with the work that I've done on the exam review, and also a PDF of the pictures of the screenshots will be available of the work in this workbook. Hope you guys enjoyed the video. Subscribe to my channel if you haven't, and I'll see you around. Take care.